Hello, welcome to the video on standard deviation. We're going to go over two different parts of it today. I'm basically going to try to explain to you what it is using some uh, various examples and then just showing you how to find it as well. So with standard deviation, basically one way to look at it is first let's go ahead and analyze what the actual word or uh, the words are. We got standard and deviation. So I was kind of hungry when I was making this, so I kind of came up with this example. Um, if you think about what a standard hamburger looks like, um, in your mind, you probably have a vision of a standard hamburger. So standard just means that it's the normal. It's what's the average, the normal, what you kind of expect to see. So that's a standard hamburger. Now, deviation means it's kind of like when you deviate from a path, you're kind of going a different way. So deviation means it's a little bit different, or it could be a lot different, just depending on how much you deviate. So when you deviate from your normal hamburger thoughts, it could be anywhere from a small deviation where you have maybe a double patty instead of one with some cheese. Looks delicious. Could be a little bit more deviation where you have these little tiny hamburgers and still a hamburger or still a cheeseburger, but it's deviating a little bit more than this one. Or you can have a major deviation where I'm not even sure if this is considered a hamburger anymore, but yeah. So standard means it's something that you expect to see. Deviation means it's going to be a little bit different to a lot different. It's just telling you it's going to be different from the standard. Okay? So when you put those together, standard deviation just tells you kind of like how your data is spread out or how your expectations are spread out. So if you expect to see a hamburger and then you see this thing, it's probably a pretty big standard deviation from the norm. Okay, if you see something like this, it's not a very big deviation from the norm. All right, so that is what standard deviation actually is. Now with numbers, because this is a math class, so with numbers, here's what it looks like. So I looked up the statistic. Said the average TikTok user spends about 52 minutes per day on TikTok. I couldn't find the standard deviation, so I just made one up. So if we know that the average person spends about 52 minutes per day on TikTok, that means that, if someone says, hey, I spend 52 minutes a day on TikTok, then you would go, oh, yeah, that's pretty average. Um, and then I tell you that the standard deviation of users is 20 minutes. So I made this number up. I'm not sure if it's 20 or not, but let's say that somebody went out there and figured out, hey, the standard deviation is 20 minutes. Here's what this actually means. Okay, we're going to figure out how to find it later. But for now, let's go ahead and just see what it actually means. So if the average person, according to this information, spends 52 minutes per day on TikTok, so here's your average person. The standard deviation is 20 minutes. So basically, this person on a number line would be right here. If I go one standard deviation to the right, it's basically like I'm adding 20 minutes to 52. So one standard deviation to the right is 72. One standard deviation to the left, you would just subtract 20 minutes and you'd be at 32. So within one standard deviation are people who watch anywhere from 32 minutes up to 72 minutes. That's telling you, okay, well, that's within one standard deviation. So if I had three people, one person said, hey, I watch for 60 minutes. Another person says, I watch about 50 minutes per day. Another's 45. All of these people fall within about one standard deviation of our normal, quote unquote, normal person. Okay. So that's what a standard deviation. It tells you, okay, is it strange that someone spends 60 minutes? Usually, if they're within one standard deviation, that's not too weird. Okay. Um, just a heads up, the next video, we're going to go more into how many standard deviations you have to fall within to be considered, um, I guess you could say normal. Um, but yeah, all right. So we have another person. Let's say another person comes and says, "Whoa, I spend a lot more than you guys. I spend about 115 minutes." So if our standard deviation is 20 minutes, that means that this person doesn't fall within one standard deviation to the left or the right. So we got to go a little bit further out, and I got to move my number line over a little bit. So remember, our normal person, and I use that kind of loosely, normal is 52. So one standard deviation was 72. I can't capture this 115 person, so I have to go out another standard deviation. So all I do is add another 20. So 72 plus another 20 is 92. So every time I add on a standard deviation, it's 20 minutes because that's what they told me that was. That's still not enough. Okay, so I got to go out one more. So 112, I'm still not there because 112 is not enough to capture that. So I got to go out one more, and I'm at 132, and 115 is between here. So that's all I got to do for my standard deviations. So this person fell about 4 standard deviations outside of our normal person. Now, this would be considered on a normal curve, this would be considered pretty far out there. So someone spending that much time. Now, again, I just made up this 20 minutes. This might be a bigger number, but this is basically how it works. Okay, so if I give you a standard deviation, this is how you would tell me how many standard deviations it falls within. So this 115 person, 115 falls within 4 standard deviations. 1, 2, 3, 4 standard deviations. All right. So I'll give you a couple of homework assignments on that. If you haven't yet, go ahead and feel free to print up your homework assignment and follow along with this so that you can kind of work along with the video. It makes it a lot easier. Okay. All right. So again, to recap, what is it? It's basically you have your normal, and the standard deviation just tells you how much certain data is from that normal, how much it deviates from there. Now, to actually find it, so how do we find this thing? Or actually, food example aside, because obviously I'm still hungry. Here's basically the textbook definition of it. It's, what is it? A measure of the amount of variation or dispersion of a set of values. So it's basically how spread out your data is. So if we go back to our hamburger example, how often do we see each one of these cases of this hamburger? All right. And a low standard deviation indicates that values tend to be close to the mean of the set. So back to our hamburger example, like if we had just a standard deviation of 1 patty, that would mean that, most hamburgers would fall between 1 patty of a single hamburger. While a high standard deviation means that you have most of your data is usually going to be spread out. Okay, so the bigger the standard deviation, the more spread out your data is. The smaller the standard deviation, the more close your data is that you have. All right, so now let's go ahead and try to find it. So how do we find the standard deviation? Now, a few different steps here. First, so just a little bit of prep here. These are going to look like a lot of steps. They're actually pretty simple calculations that we're going to be doing, so just kind of bear with me here. First, we're going to find the mean of the data. So if you remember how to find mean from our last video, you just add the data up and then divide by how many pieces of data there are. So finding the mean is the exact same thing as finding the average. So like I said, it's how far, standard deviation is how far whatever that data is from the average. So we got to find the average first. After that, we're going to subtract the mean from each of the data points. What this does is this tells us what each piece of data, how different it is from what we would normally expect. The mean is what we'd normally expect. This step tells us, okay, this is what we normally expect. Here's another number. Is that very different than what our mean was, or is it only a little bit different from what our mean was? Next, we're going to square those results. What this does, it turns everything positive for our next step. We're going to get rid of the square later on. The next step, we're going to find another mean. So we're going to find the mean 2 times, all right? And then after that, we find that new mean. This new mean, by the way, is called a variance. Not really too important for what we're working with right now, but it's named the variance. When we take the square root of step 4, that will be our standard deviation. Okay, so we got 5 steps here. So let's go ahead and walk through this. I'll put this up to the side so that we can kind of see them as we're doing them. Now, these are just random pieces of data. I didn't put it into context at all. I probably should have, but I didn't. So let's say that these are like, I don't know, shoe sizes or something. But these are the pieces of data that you're working with. All right, so first off, you're going to find the mean of the data. So to find the mean, you just take all the numbers, add them up, and divide by how many there are. There are 5 pieces of data, so I'm dividing by 5. Okay, this gives us 7.8. So 7.8 is our mean. So that's the first step. Now what we're going to do next is we're going to take that mean of 7.8 and we're going to subtract them from each one of our data values. Because right now I know this is my average. This is my normal. If this was shoe sizes, this would be my normal shoe size is 7.8. So now I got to figure out, okay, each one of my pieces of data, how far is this from what I consider normal? So the way to find out how far something is, you just subtract it. So I'm going to take the 7.8 and I'm going to subtract it from each one of these data points. Now I'm going to put one up here just so we can kind of keep track of what it was before. So each one of these data points, I'm now going to subtract my mean from. Okay, so it's negative 0.8, 2.2, negative 3.8, 5.2, and negative 2.8. Now, I got problems because I got negatives here. So that's what this next step kind of accounts for, or makes it so that it doesn't mess up our calculations later on. So I'm just going to take off those 7.8s. We're going to take each of these new numbers that we got and we're going to square them because that will get rid of the negatives. It also magnifies the differences so you can see if a number's kind of far away versus one that's kind of closer, without them looking so close together already. So we're going to square them. So each of these numbers squared, and we take a look at that, -2.8 squared, it's just going to, everything turns positive, right? And like I said, it exemplifies how far away something was. So this 4, even though it doesn't really look that far from the 7.8, when we square it, we can see that this is a lot bigger difference than this 7 right here. Okay, 7 is really close to 7.8. 4 is pretty far, so squaring it kind of exemplifies how far away these values are from our average. Now, the next step is, once we have these numbers that we squared, we're going to take another mean using these new numbers. All right, so each one of these new numbers, we're going to take the mean of, or not each one, but we're going to take the mean of all these numbers combined. So we're just going to add them all together, and there's still only 5 data points because I only started with 5. So you're just going to add them up, divide by 5, and that should give you 10.96. That is called the variance. Okay. Again, that's the variance isn't too important to what we're doing, so we're not going to cover that too much because we have to get the variance in order to get our standard deviation. Now, remember, before we squared our results to help us kind of see how far apart the differences are. So now we're going to square root just to kind of say, okay, I realize that I squared the data now. I'm going to square root it just so I can kind of get back to how far apart they are. So the square root of 10.96 is about 3.31. And that's it. That's how you find your standard deviation. Okay, just those 5 steps. Like I said, it's basically finding the mean 2 times, some adding and subtracting, and that's it. Okay, it's a lot of small steps. Just make sure you follow these. And remember, I think you might have covered this before. I'm not sure if they cover this in middle school math, but basically that's how you do this, right? Now, what does this actually mean on a number line? Now, I'm not going to ask you to actually do this part, but just to kind of show you what this means. So you got 7.8 is your standard, or not your standard deviation. That's your that's the mean of your data. So that's the normal number is 7.8. If this was shoe sizes, that would be your normal shoe size. So just like we did with the hamburgers, 7.8. If I go 1 to the right and 1 to the left, this would be within 1 standard deviation, given this data. So a lot of our data falls within that range of 1 standard deviation. Now, even more of our data, if I go out 2 standard deviations both ways, that captures basically all the rest of our data. And we're going to go, like I said, into what's called the normal curve in our next video. But basically, this is what we're going to expect is most of our data is going to fall within 2 standard deviations. Okay, so, and then we just saw that happen right here. All right, so that's within 2 standard deviations. Now, that's basically how you do this. This next example is basically just going to show you a way of organizing your work, and this is how most teachers show it. It's up to you if you want to do it this way, but it is helpful when you have large pieces of data. I'm just going to do it with the same example that we had just so you can kind of see how it works. So basically, you just make a 3-column table. The first column is for your data. The second column is for to show basically step 2 where you subtract it. The third column is so you can show the data squared, the data versus the mean squared. Now there are symbols, so you can write this fast. The symbols, so again, find the mean. You got to find the mean first. That's always your first step. We already found it for these pieces of data. It's 7.8, so I'm just going to put that up there. So your first thing is that these have actual symbols because math people like to write less. So our data, we're going to call those x values. Mean is x bar. You're going to see an x with a little bar on top. That's the symbol for mean. And then we just plug those into there. So again, we just call our data x's. This is x minus the mean. That's 7.8 was the mean. And then we just plug it in and square it. Okay. So I'm going to take all my data values, 7, 10, 4, 13, and 5. Okay, that's step, wait, we're on step 2. Sorry. Step 2, subtract the mean from each of these data points. So I'm going to take each one of these. I'm going to subtract 7.8. So this is, like I said, this is exactly what we did with the previous example. It's just that this is organized in a different way. So you can choose to do it this way if you want to. After I subtract that, I get these values. Then I'm going to take those values, I'm going to square them. That's the third step. That's the third column, third step, basically. Take them and you square them. All right, and you square them, you get these values. Now the fourth step, you're going to find the mean of those new values. So I'm going to take all these numbers that I just found, find the mean of. By the way, if you have any negatives on this step, you did something wrong because this squaring step should have turned everything positive. All right, so I'm going to add all those together. I get 54.8. Divide by 5 because I'm finding the mean, so I got to divide by how many pieces of data there are. I get 10.96. Again, that's the variance. Now, when I take the square root of this variance, of this 10.96, that will give me my standard deviation, which is about 3.31. And then that's it, okay? So those will be the last couple problems you'll have on your worksheet, is just finding your standard deviation with some data sets. Feel free to ask me questions if you got them, or loop mail me, okay? Take care. Hope everyone's doing well. Bye-bye.